Welcome students. We are back with another lesson. We'll discuss refraction at spherical surface. So in this topic we will derive the relationship between the distance of the object, distance of image and radius of curvature of a spherical surface by using sign conventions and some assumptions. Consider a refracting surface. Suppose this APB is your refracting spherical surface. Okay, this surface separates two mediums. The first one is your rare medium. This medium is rare, and denser medium. This is your denser medium. Fine. So your refracting surface APV separates two mediums, your rare medium and the denser medium. Fine. Now, now let P be the pole, C be the center of curvature. If C is the center of curvature, then this distance, which is denoted by R, is your radius of curvature. And in this case, my radius of curvature equals to this distance. So I can write my R equals to PC. Fine. Now consider a object O which is placed on this principal axis. This is your object O. From this object O, consider a light which starts from this object O and it moves in this direction. Fine. Now after falling on your refracting surface APV, what happens? Refraction. Now after refraction, the light bends towards the normal since it is moving from rare to a denser medium. So the light changes its direction and it bends towards the normal. Now consider your second ray which starts from the point O. Now this ray passes undeviated since it is passing along the principal axis. Now this your refracted ray 1 and your refracted ray 2 intersect at this point. So a image I will be formed at this point here. So if O is your object, then this distance PO PO is your object distance which is denoted by small u, And if I is the image form, then this distance from P to I, this distance is known as your image distance, and it is denoted by small v. So small v equals to Pi, and r equals to radius of curvature will be the distance between the pole and the center of curvature. So this is P C. Fine. So if you have any confusion with this figure, you can ask me again. I will re-explain it to you. Fine. Now you draw a line NM. Draw a line NM perpendicular to your principal axis. Fine, this line is your principal axis. Now let us consider this ray. It makes some angle. So let us denote this angle as alpha. This angle as alpha. Now consider this angle. Now let us consider this angle as beta, and this angle as gamma. Okay, let us draw these three angles, your alpha, beta. Now consider your triangle NOC. Okay, this triangle, this is your triangle NOC. Okay, consider this yellow triangle. This yellow triangle is your triangle NOC. Fine. Now in this triangle, consider this angle. This is your angle of incidence. Now if you look properly, this angle is exterior to the triangle NOC. Now let's quickly revise your exterior angle theorem. This done in your class 9 and your class 10. I will just do a quick revision. Now according to this exterior angle theorem, now consider this triangle. Fine. Now consider two angles, your angle A and your angle B. These two angles are opposite to your exterior angle, angle D. Fine. So the exterior angle theorem, the exterior angle theorem states that the the sum of the two opposite interior angle, your angle A plus angle B, should be equal to your exterior angle, angle D. Fine. So this is your exterior angle theorem, or I can say exterior angle property. Fine. So we will use this concept. So now let us again consider your triangle NOC. Fine. Fine. Consider this yellow triangle. Now in this yellow triangle, this angle I is a exterior angle. Fine. So from the exterior angle theorem we know the exterior angle equals to the sum of the two interior opposite angles. So the opposite to this exterior angle is this angle, your alpha, and this angle, your gamma. So according I equals to the sum of alpha plus gamma. Right? Now, similarly, you can consider your triangle NIC. Okay, consider your triangle NIC. This triangle. Find this yellow triangle. Again, in this triangle, using the I can show that the exterior angle gamma, this angle equals to the sum of the two opposite interior angle. So the two opposite interior angles is your angle R and your angle beta. My gamma equals to sum of R plus beta. Gamma equals to R plus beta. Or I can also write my R as gamma minus beta. Fine. Now we will make further few more assumptions. Now consider your triangle NOM. Consider this right angle triangle. Okay. Now in this right angle triangle, tan of alpha equals to the opposite side NM divided by your adjacent side OM. Fine. So alpha can be written as tan of alpha, or you consider only this part, tan alpha equals to Nm by Om. Fine. Now we will consider your alpha to be very small. Now if alpha is very small, then I can write alpha is almost or approximately equals to tan alpha, which in turn equals to Nm by Om. Nm is the opposite side, Om is the adjacent side. Now, since your point P and your M, they lie very close to each other. Okay, P and M lies very close to each other. So instead of using this m, I can also write p. So if I replace the m with p, therefore my alpha can be written as nm by op. Fine. Similarly, now consider your triangle NMI. Okay, consider this yellow triangle. Now again we will follow the same procedure. So tangent or tan of this angle beta equals to the opposite side NM divided by the adjacent side MI. Since beta is also a very small angle, so I can write beta equals to tan beta, and tan beta equals to the ratio of the opposite side nm divided by your adjacent side mi. So nm by mi. Again, m and p lies very close to each other, so instead of this point m, I can write p here. So my beta can be written as nm by pi. Fine. Consider this triangle. Fine. So gamma, since your angle gamma is very small, so I can write gamma is approximately equals to tan gamma. Fine. So what is tan gamma? Tan of this angle gamma, it is equal to the ratio of the opposite side nm by your adjacent side mc. Now again your point P lies M. So instead of MC, I can write this distance as PC. So your gamma equals to Nm by PC. Fine. So these are the three assumptions we have to make. Fine. Now, if you have any confusions up till now, you can ask me and I will re-explain it to you again. Fine. Now, from our Snell's law of refraction, we know sine I by sine R equals to mu2 by mu1. Fine. If you remember, I had already explained this Snell's law. According to the Snell's law, the sine of angle of incidence, what did I say? If you write sine of angle of incidence, you will write the angle of incidence is in which medium? Your rare medium or denser medium? It is in the rare medium. So if it is in the rare medium, you will write down the refractive index of that respective medium in the denominator. Fine. Similarly, sine of R. So R is in which medium? Rare or dense medium? It is in the dense medium. And what is the refractive index of dense medium? Mu2. So R is in the denominator. So you have to write mu2 in the numerator. Fine. So you can remember the Snell's law like this. Sine I by sine R equals to mu2 by mu1. Now again, your angle of incidence I and your angle of refraction R are very small. If your I and R are very, I can write my angle of incidence as approximately equal to sine I. So instead of writing sine I can simply write I here. Fine. Similarly, your angle R is also very small. If R, your angle of refraction is small, then R is approximately equals to sine of R. If sine of R, then instead of sine of R, I can simply write R. So I can write I by R equals to mu2 by mu1. Fine. Where I is the angle of incidence, R is the angle of refraction, mu2 is the refractive index of the denser medium, mu1 is the refractive index of the rare medium. Fine. Now, after writing I by R equals to mu2 by mu1, I can cross multiply. So, mu1 times 2, mu2 times R. Fine. So, angle of incidence we had already derived. This I equals is the exterior angle to alpha and gamma. So instead of I can write the sum of alpha plus gamma. So instead of I have written alpha plus gamma. Similarly, for the case of R, for the R also I have derived. See what we gamma is your exterior angle. Gamma equals to the sum of the two opposite interior angle R plus beta. Fine. So from here I can also write R as gamma minus beta. So this one I have written it here. Fine. Instead of R I have written gamma minus beta. Now now according to our assumptions I can write alpha as Nm by OP, gamma as Nm by PC. Similarly, gamma as Nm by PC and beta as Nm by Pi. Fine. So we will substitute our assumptions. Therefore, I can write mu times Nm by OP plus Nm by PC equals to mu2 times Nm by PC minus Nm by Pi. Now, I can take this Nm and Nm common, isn't it? Both sides. If I take Nm from common, what am I left with? 1 here. If I take Nm common, what am I left with? 1 here. So here I have taken Nm common. Similarly, on the right hand side, I'll take this Nm common. So I'm left with 1 on this part. I'll take Nm common. I'll be left with 1. So Nm common. Now since Nm is in both the right hand side and the left hand side, so I can cancel Nm and Nm. Fine. Therefore I'll have mu1 equals to 1 by OP plus 1 by PC equals to mu2 times 1 by PC minus 1 by Pi. Fine. Now let's open this bracket. If I open this bracket, mu1 times 1 is mu1 divided by OP. Similarly, mu1 times 1 is, if I open this one, what I will get is, I'll write down here, okay. Mu1 by OP plus mu1 by PC equals to, I'll open this bracket here also, I'll write mu2 by PC minus mu2 by Pi. Fine. So now I'll write this mu1 OP and mu2 Pi together. Fine. So I'll send it to the left hand side. So if I send it to the left hand side, this negative sign mu1 by OP plus mu2 by Pi. Fine. Now I will send this mu1 by PC on the right hand side part. So if I be left with mu2 by PC, and this plus, if it goes to the right hand side part, it will become minus. So I will have mu2 minus mu1 by PC, mu2 minus mu1 by PC. Fine. Since this denominator PC is same, so I can take this denominator, or I can write like this, mu2 minus mu1 by PC. Fine. Now let's use the sign convention. Now according to the sign convention, direction of the incident light, okay, the incident light is always directed from left to right. So any light or any distance in this direction will be taken positive. So let us consider your first distance, this distance, your object distance, PO, or I can also write OP. Now since it is opposite to the incident light, so I'll write minus U. Fine. Your image distance Pi, this one, which is denoted by V. Now since this is in the direction of the incident light, so Pi equals to plus V. Fine. Now consider your radius of curvature. The radius of curvature PC. This distance is the radius of curvature PC. Now PC is also measured in the direction of incident light, so this will be also positive. Fine. So instead of OP, I'll write minus U. Instead of PI, I'll write plus V. Instead of PC, I will write plus R. Fine. As mu2 by V, mu2 by V. I can send this minus here. So minus mu1 by U equals to mu2 minus mu1, mu2 minus mu1 by R. So this equation is the equation of refraction at spherical surface. Fine. So this relation or this equation forms a relation between small u, your image distance V, and the radius of curvature R. Fine. So if you know the refractive index of the denser medium and the refractive index of the rare medium, fine, and out of this three quantities, any one quantity, any two quantities, then you can find the third quantity. Fine. So this expression is your expression or the refraction at spherical surface. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.